Okay. All right. Hello, everybody. Today I'm going to be talking about the software development process and specifically talking about the role that developers play in the Samvera community. So quickly, a little bit about me. My name is Kai Stroud. My pronouns are he, him, his. I'm a senior software engineer at softservebyscientist.com, formerly known as NotJate. I've been a developer now for just over 4 years and have been working in the Samvera community for almost as long. So a quick overview of my presentation, what we're going to be talking about. I'm going to be discussing the development process from an individual developer's perspective, as well as then expanding the scope out a bit to talk about how contributions happen in the community, the Samvera community specifically. So first, the development process. This is going to be a brief peek into our day-to-day. And it is worth mentioning that I will mostly be pulling from my perspective as a developer at SoftServe. I know that many of my peers have similar processes, so there is likely some overlap. But like I said, it's just worth mentioning, I think, that this is coming from my specific perspective and our processes mostly. So at SoftServe specifically, we use an agile Scrum process. This is a combination of two different project management methodologies. Both are very complex, and there's a lot of information about both of them, so I'm not going to be diving into that. The main thing worth noting is that it is a project management system that relies on incremental development. And what that means is that it mostly focuses on iteration and delivery. So we work in 2-week intervals called sprints, and the goal of each sprint is to build the most important features and fix the most important bugs first. And then at the end of those 2 weeks, we come out with a potentially deliverable product. So yeah, again, a series of bug fixes, parts of a new feature, or maybe a whole new feature itself. It is really focused on small actionable goals that lead to real results quickly. So we start with a product backlog. This is all of the issues and features for a specific product. And then in the planning leading up to the sprint, that backlog is filtered down into a small set, again, almost always prioritized by the most important bug fixes and features. Then the 2-week sprint begins. Sprints are usually worked on by a small set of developers, at least, again, in my experience, usually somewhere between 3 to 5 or 6 maybe developers all working on the same batch of issues in that sprint. And then at the end of the sprint, there is, if the sprint was successful in finishing, getting certain things ready to be delivered, then that gets packaged into a new release for the software, and then that gets pushed out to all of the users. So we organize our tasks using something called issue boards. If you saw Julie Hardisty's lightning talk earlier today, this will look familiar. I'm actually, I'm really glad that she gave that talk because I think it adds a lot of context to parts of what I'm going to be talking about. So this is a board with different columns. The individual items in each column are called issues or tickets. They refer to an individual task, either one bug fix or a feature, or maybe one specific piece of a large feature. Typically, these issues move from left to right across the board as work gets done, and they're tracked that way by project managers, developers. And these boards are also not strictly for developers. At SoftServe, we often collaborate with our clients on boards like these. And also, Julie mentioned how the community can participate in reporting issues and working on these boards, even if they are not developers. And these are pretty common. If you report a bug on any app or website, etc., really any kind of software, it'll probably end up on a board like this for whatever company or community is working on that piece of software. So each ticket contains a few things. This is the template that we use at SoftServe. So each of our tickets has a summary of the bug or the feature, a list of acceptance criteria to really nail down what needs to be done in order to consider the task as completed. Screenshots, videos, or wireframes, really just supportive media to help describe the ticket itself. and then also testing instructions of either how to replicate the bug or verify that the feature covers all the bases it's supposed to and does what it's supposed to. Like I said, this is the specific template we use at SoftServe. There are other templates, and a lot of them often have similar elements. So again, like Julie went over earlier today, Hyrax, the template that Hyrax uses is a descriptive summary, a rationale, expected behavior, actual behavior, steps to reproduce the behavior, and then also related work. And then not explicitly mentioned on my slide here, tickets often also have references to related tasks or code, and then also comments for discussion. Here's a simplified version of a typical development cycle. Most of these bubbles have different steps within them, but just keeping kind of a high level overview here. Starting at the top, we start with a request. So the request comes in from a user or another developer who found a bug. The request is investigated, and if it is found to be valid, then an issue is created on the issue board. And then that issue or ticket goes through a triage process, again, usually as part of a sprint planning meeting to give it a priority in relation to the rest of the backlog. After that, then development starts on the ticket. This is all the code changes that happens. And then once the developer finishes the code that they're writing, it goes through code review. This is when another developer reads through the code to make sure that there aren't any errors or potential bugs or anything like that, a quality control step. And then there's the quality assurance step. This happens typically, again, pulling from SoftServe, we use something called staging sites. These are often private sites that are on the web that we deploy code to for testing purposes. So like I said, they're not typically available to the public, and then our clients would go in and use that as a playground for testing to make sure that the feature that they've requested is doing what it needs to do and behaves as expected. And then also for developers or specific QA engineers to go in and test to make sure that there aren't any bugs. If the code passes the QA step, then it gets deployed to the live site. So this is the actual website that users use, and then this is when the feature or bug fix becomes available to everyone using the site. And then after the deploy step, there's, again, a verification step within that to make sure that everything looks okay after the deployment. And then comes maintenance. So maintenance can cover a lot of things. Often this includes security updates to software that the application relies on. It could be bringing upgrades from the code base that the project is based off of. So if you have a Hyrax application, Hyrax is obviously always being developed on and new versions are being released. Your application doesn't automatically stay up to date with those. And so bringing in those updates could be part of maintenance. And then also new bug fixes and new features. And then that leads back into the request step. So far, mostly been focusing on what an individual developer's day-to-day might look like, but now I'm going to be talking about how that plays into the rest of an open source community like Samvera. So quickly touching on open source, I'm sure most people listening to this talk know what open source is, but in case anyone doesn't, I'll just quickly go through the what and why of open source. So basically, it's the opposite of proprietary, proprietary being software that you pay for and is private. It's usually offered by a specific company for profit. There are many benefits to open source. One is that it's public. Anyone can go and look at the code. It is community driven. So again, the software is not being pushed forward by a single company's interests. Many eyes on the same code creates trust between the community. Lots of different people from different backgrounds going in and collaborating helps to catch a lot more issues before they make it to the production site, and really makes solid software in that regard. And then also the fact that anyone can contribute to open source software. So you have the power to make the changes that you want to see in the product. How contributions happen specifically with code. Usually, again, with the Hyrax application or maybe a Haiku application, you would branch off of the main community code base in something called a fork. It's your own copy of that code base. In that copy, you can do feature development, make bug fixes. You can also make any customizations you want to. And then for generally applicable changes that you make, so again, if you fix some bugs or added a cool new feature, you can then merge that code back into the community code so that everyone else has access to it. And it's really neat though, because any specific customizations that don't apply to everyone else, like if you change the name of the application to be your institution's name, you just don't contribute that back so that everyone else can use their own name. So if you take this and you put it at scale, you have many institutions all making contributions at the same time into the Samvera tech stack. And then as that happens, those improvements, bug fixes, and new features get put back into each of the institution's code. And this way, everyone benefits from using open source software like this. And again, with many institutions doing this kind of work, this multiplies the number and the speed of improvements that happen. So that's a quick overview of what the development process looks like. You can reach me on Slack using my handle or by email. And if we have time, I will take questions.